Hi, it's Jan Beta, and today we're going to try to repair this Commodore VIC-20 board that's in very poor condition. This is an NTSC VIC-20, the cost-reduced board with the Commodore 64 style power socket. And this was donated to me by John, thank you for that, who sent me a lot of stuff, including 5 VIC-20 boards in various states of disrepair, as he puts it. And this is another board. I just checked this and thought it would be broken, but it actually works. I'm not sure if this fully works yet. I haven't tested it fully, but we have something to swap chips from. This was powering up at least, and this won't power up in this state because it's missing some crucial components to even power it up. So on this side here, it's missing the power switch, which of course is pretty essential for powering this up. This uses the same style power switch as the Commodore 64, so I have some of these replacements. It also uses the same connector for the power supply, which is also missing on this board. It's also missing the joystick port here. That's also the same connector as on the Commodore 64. So I'm probably just going to salvage that from one of my spares boards. It's not crucial for operation, but would be nice to have that on there once we have this working, which I hope I'm going to achieve. Another missing part is the AV out, so video and audio out. The chips seem to be all here, thankfully, except for this transistor, originally a 2SD880, I think. Yeah, that's what it is on the other board. And that switches the motor voltage for the data set. So it's not very crucial for initially repairing this, but I'm still going to have to find a replacement for that. Other than these missing parts, it seems to be intact as far as I can see so far. There are some bodge wires, but as you can see, there's the same bodge wire on the working board. So this is an original Commodore bodge wire from the factory. We're going to need the AV out and the power switch and the power socket to be able to test this at all. So let's see what we can do there. That's the first step, just replacing the missing components that are crucial for powering this up. So I think the power socket I'm just going to take from my C64 spares board that I have here. Yeah, this one still has the power socket and it is the exact same footprint as on this 250425 board C64 that I already salvaged some parts from. I'm going to desolder a joystick port and the power connector. Unfortunately, the video connector, the AV socket here, is not the same because the C64 has more pins, starting with the second revision basically. The first revision had the same 5-pin connector that the VIC-20 had, but I have a replacement for that that doesn't fully fit, but I think we can make it fit. We're going to see. So let's desolder these parts here from the C64 first. Going to do some cleaning while I'm doing this. It's not so dirty that the dirt would prevent this from running, I think, but it's a bit dusty and things like that. So and there's a screw still in here that has a part of the case still on it as well. So we're going to remove that. But yeah, it does look rather in good shape, actually, especially the back side of the board. No broken traces that I can see so far. No desoldering attempts on the chips. There has been some resoldering on the connectors, but that's nothing to worry too much about. These sockets are relatively non-trivial to desolder, by the way. There's a lot of ground planes, but we should be able to do it. Hey, there we go. Yeah, these are screwed in as well. There we are. And that should fit our VIC-20, I hope. That is the exact same connector they used for the VIC-20 and the C64. So just soldering the parts on this side in after removing some of the solder that's left in there. Just a tiny bit of cleanup here. This might need a bit more cleanup. Yeah, looking good. So just using the exact same screws that were in the C64 to fix its smaller sibling, or its older sibling. Okay, let's solder that in, I guess. Don't know why I'm doing the joystick part first, actually. I'm a bit tired today. This is the least necessary part we need. Although, one might argue, the joystick is an essential part of any retro computer system. So that's in there nicely. This is our power. Yeah, and that seems to be the correct footprint as well. So this is indeed slightly, ever so slightly different. You can see these ground connections here in the front. This is the ground connections. These two, right at on the edge here, are the ones that were used previously, and these are the ones that this connector has, the ones that are closer together. And the VIC-20 has both holes there for both footprints. That's pretty nice. Otherwise the footprint is the same, but this would be a game breaker. I think we're going to see the same with this AV socket that I'm going to install. That has the wrong footprint for this, but we're going to work around that in some way, I'm sure. So yeah, let's solder this in completely, I guess. Tackling one problem at a time. This is not really a problem so far, but yeah, we're going to have to see what's wrong with it, really. This wasn't used as a donor for no reason, I'm afraid. The power switch should fit in here as well in some way or the other. Some of these pins are a bit bent, probably because I stored it in a little drawer. So there we are. That's our power switch. That should be in nicely. Now for the AV socket there. That's a bit of a more of an operation because the one I have doesn't exactly fit the footprint. So here's the thing. The connector I have for this has the matching footprint for the connections in the back here, but these front pins are too close together. So maybe we can bend them over and attach some wires to them. These are the ground connections, so they are pretty crucial. Probably going to solder them from the front side here. Just making little wire to go in these holes. This is, of course, this is a workaround, and these parts you can still pretty easily get. These are just standard DIN connectors. And the 5-pin DINs are also the same ones that are used for MIDI still, I believe. So plenty of these. This is not a rare part at all. I just don't have another part that's a better fit. So let's see, just adding some solder here. There we go, that should do. Instantly fell off, of course, so, but we are going to be able to make these fit these holes, I guess. It's gonna be fine. I hope. Not even sure if we need a connection there. That's our ground connection. I think that is pretty crucial for our AV. So, bit of a workaround, but it's going to do. It's a bit at an angle, but I don't mind that. It's probably still going to fit in a case fine as well. And yeah, I need to source a better one of these connectors at some point. This is the makeshift one, but we should have contact to the ground pin there, which is used for the shielding probably in most cables, so it's pretty crucial to have that in place. I'm going to remove the remnants of the VIC-20's shielding that are still on this part here, as I just noticed. And then we can start troubleshooting, I guess. This is just on here. Yeah. So that's the soldering portion. For now, we're going to see if we're going to have to do more soldering. But maybe this is a good point at which we can actually hook this up to a monitor and see what it does. One thing you always want to do while you're doing a visual inspection of the board is to see if all of these little capacitors are properly soldered down. If the chips sit in their sockets, the socketed ones at least, sometimes they just fall out or just get bent slightly or something. Fuse looks intact, we're going to measure that. Let's try to hook this up to some power, I guess. Pretty sure this board itself is intact. I didn't see any broken traces, but sometimes you don't see them. There don't seem to be any burnt components or anything like that, which would be a reason for me to not power this up. Yeah, we're going to see. With a known good power supply, of course, which is the same one you would use for a C64. Okay, fingers crossed that this does something useful. Now it has juice coming in through the power socket here. Let's switch it on. Oops. It's buzzing. Yeah, no, it's just making noises. That's not good. That's absolutely not what we want. Let's test some voltages, I guess. Should be able to test the voltages the same way as on the C64. Because this has the same user port. And there's two gaps in here, one's here and one's here, and one has the 9 volts AC, which is this gap here, I think, and one has the 5 volts DC, which is the other one. And we should be able to measure those voltages there, if everything is okay, which it clearly isn't, but yeah, we're going to see. This basically uses the voltages from the power supply directly, I believe. So this is 4.8, that's not correct. It's too low, something's shorting out here. And this should be around 10, which it is. So 9 volts are good. The 5 volts are too low. 4.8 was what I measured there. So that might be due to something shorting out. I'm probably just going to remove some of the chips. We don't have any overvoltage, which is good. Possibly I'm going to put the transistor in there as well. So kind of funny story regarding this transistor, which originally on the other VIC-20 board that I have at least is a 2SD880 transistor, standard NPN transistor here to switch the voltage for the dataset motor on this connector. And I wanted to know if I can just use the equivalent transistor in the same position on the C64 board, which is a TFw8b in this case. I think they used the exact same transistors at one point for the C64 and the VIC-20. I just wanted to make sure if this is an equivalent transistor without going through tables and checking the values of these transistors, so I can just desolder this and put it in there. And Google suggested that I replace it with an EEPROM. I'm probably going to put the AI nonsense that it told me into the video here so you can read it yourself. Please don't use LLMs or AI or any of that newfangled stuff for anything like this. I was just using Google. I usually don't ask any ChatGPT or LLM stuff, but Google now has that built in, and the first answer you get is the LLM, Google's LLM, Gemini or whatever it's called. It's crap, don't use it. And it also messes up the planet. It's very energy hungry. Yeah, I'm not a fan. I like computers I can understand like this. So I think, yeah, that's probably the way to go. I'm just going to desolder that from the C64 and put it in there. No video on a VIC-20 can mean basically any chip as well, similar to the C64. I think the circuit for the tape motor is basically the same on both machines, so should be good anyway with this transistor. And I looked it up elsewhere and asked around, and yeah, should be fine. There we go. So yeah, I'm just going to try to remove the VIC chip, I think, and see if that changes our voltage output. And that would be an indication for that being broken. There we go. Yeah, that's a bit better. That's 4.9 volts now. We have the luxury of having a working VIC-20. Just checking if any of the chips gets hot. They should get warm, tiny little bit, but not hot. Yeah, and that's what they do. So, could check the VIC chip in a working machine. We could check all the chips, basically. That would probably be the easiest way forward to see if our main ICs work. I'm inclined to do that because it's literally the easiest way if you have another VIC-20 board that does work. So I just hooked up the working VIC-20 board. Let's see if it still works. That I tested earlier. Yeah, and that's the output we would expect from a working board. It's an NTSC version, so it's a bit different aspect ratio wise than what I'm used to here from my VIC-20s that I worked on previously. Yeah, but that's what a working VIC-20 output looks like. So what I'm going to do is to put our VIC chip in the working board, removing the other VIC chip, which is the exact same issue, just a slightly earlier one from 82. And the one from our broken machine is from 83. But we can determine if this is one of the culprits by doing this and powering on the machine. And then I'm going to do the same with all the other chips, I guess, because everything is socketed on both of these boards, thankfully, except for the RAM and the small logic chips. But the ROMs and the CIAs and the processor are all socketed on both of these. So that makes things considerably easier in this situation. Otherwise, you would have to get the oscilloscope out and check the input and output of the VIC chip, of course, which I still might end up doing. But we're going to determine that this chip is alright at first, I guess. Which would be my first suspect to be broken because of that buzzing noise that it made. Let's see. Yep. Yeah, there's definitely something wrong with that chip. That was just a gut feeling, more or less. So, yeah, bad VIC. So that's at least one of the culprits. I think I'm going to continue doing it for the other chips as well. This one's definitely not doing what it's supposed to do. We could just try the good chip in the broken machine and see if that fixes it. Not sure if I want to do that just yet, because in case there's something wrong with the voltages, there may be other stuff that's wrong and potentially damaging the chips, although we didn't have any overvoltage. But it still might be a good idea to check the other chips and see if those are all right. So I'm just going to swap everything around and determine if everything works, or what works and what doesn't. Which I know is kind of cheating, but yeah, it's an easy way. The ROMs are always a suspect on the VIC-20. So if this is broken, this is the CPU. If this is broken, this shouldn't start up at all. But it does, so the CPU is probably alright. Which is a classic 6502 in this case, by the way. The ROMs. Yep, that's okay. So maybe it was just the VIC-2 after all. And I'm not testing these in depth. I'm just going to see if any of these chips causes the machine to not start up. That saves me a lot of trouble. Going to do some more in-depth troubleshooting later. So these are all right so far. That's okay too. So it's kind of looking good, actually. So chances still are that it's just our VIC chip, which of course would be the worst case, basically, because it's the least replaceable chip of them all. The 6522s you can still find relatively inexpensively. New old stock even. Same with the 6502. So the only broken chip of all the socketed ones that I found was the VIC chip. So let's try the good VIC chip in the bad machine and see if that fixes it fully or if we have other problems. Which may very well be, but it might just be just the VIC. So let's see, fingers crossed that was the culprit. Maybe it was. Yup. Okay, we found the culprit for this not working. It was a bad VIC chip. Kind of always want to say VIC-2 because I'm working so much on C64s. We're going to test this fully in a second. So this VIC is okay. I'm just going to write okay on that. So my friends at the Future Was 8-bit just sent me this, which arrived today actually. The Penultimate +3 DCR cartridge, which is the latest Penultimate cartridge, and I'm going to make a separate video about this, I think, because it is so feature-packed. You probably heard of the Penultimate cartridge. I can highly recommend these, even the predecessors. They are really, really good feature-packed cartridges which have all kinds of memory expansions you can ever dream of for your VIC-20. They have a lot of software, now even more, and this new version integrates an SD to IC, so you can put an SD card in here, full-sized SD card slot, and you have a little connector here that it comes with a cable to connect that with your IEC disk drive port, and you have a disk drive emulator in here as well. This now also has a turbo disk speeder and a DOS wedge, so you have better DOS commands. But as I said, I'm going to go into this in more detail in a separate video. Love this. Thank you so much for sending this to me. Yeah, this gets too little attention in the YouTube realm, as does the VIC-20. So I'm going to counter both in this video, kind of. And there's going to be more about this in a couple of weeks, probably. So the reason I got this out is A, it's a really good cartridge, and B, it has, among many other things, a built-in dead test. So if we hold down this button on the cartridge and power it on and then release the button, it's going to go into dead test mode, and we have a memory check and things like that. So that's a dead test for the VIC-20, which Dave, who also designed the whole Penultimate cartridge, came up with Tynemouth software. I'm going to link the website in the video description. I highly recommend that. Very nice, detailed descriptions of hardware repairs on old computers and making of new hardware for old computers. Really friendly person as well. So shout out to Dave. Thanks for making these things available for us. So let's see what the dead test actually tells us here. Going to release the button, and there's our dead test plus. And this basically goes through all the RAM that is available in the system here, which is not much in the case of the VIC-20. It's also static RAM in the VIC-20, which is kind of interesting. And two different kinds of static RAM. Not much memory compared to everything that came after the VIC-20, but it was a very affordable computer when it came out. And it's still a lovely computer. And there were, right from the start, basically, there were expansion cartridges available with more RAM. So this is looking good so far. It also tests the ROMs that we already kind of tested, and the color RAM. It's using a RAM font and the font from the character ROM, swapping between both. So you can, if the characters look garbled when it's using the character ROM, you have a bad character ROM, you can see that. I think that's the purpose of that. And this, of course, doesn't test any of the ports or anything like that, just a basic RAM test and system test. But this looks good, very promising so far. Oh, and it's also doing a sound test. Yeah, it passed the first cycle. So this seems to be all right so far. But there's more tests that we can do. I also got another donation from John, which is the full test harness for the VIC-20. So this is the VIC-20 Diagnostic cartridge, which John also donated. And we also have the whole test harness. That's similar to the one for the C64, but with the appropriate connectors for the VIC-20, of course. I believe this is also a project that Sven Petersen offers on his website. I'm going to put a link to that in the video description. We have a connection to the joystick port, so this is going to test all the ports. This is our cassette port, and this is our disk drive port, or IEC port. You can also connect the printer to that. So, let's see what that does. I've never used this, no idea if this works, if the contacts are clean enough for this to work. We get a light. Oh yeah, it's starting up. Just going to start this again so you can see the output from this cartridge, which I am seeing for the first time myself. I'm not sure how this is supposed to look. I'm not sure this red line is supposed to be there. The RAM test, the first RAM test passed. We have 0 days displayed there. Screen gets scrambled. ROM check FA bad. Far bad. So the RAM seems to be alright. Maybe we'll clean the connectors and see if that is accurate. Because the connectors are really, really dirty on this one. And the ROMs being bad is actually a very common fault on these, of course. So what I usually do with these connectors, these edge connectors, is to use the pencil eraser. And that usually works pretty well. So here we are, the dull contacts, and I'm using my eraser. And of course we want to do this from both sides. Look at that, that's already so much better. So this is the way to clean gold contacts. And you want to, of course, get rid of the eraser residue after that. I usually use some alcohol after that. So yeah, let's clean the other side as well, but that's not as dirty normally. Yeah, so much better. So let's use some alcohol on here. To get rid of the eraser stuff. And let's try that again. Also probably a good idea to put some contact cleaner into the cartridge port. Yeah, something is not quite checking out there. But it seems to mostly work. 0A bad. Something's wrong with the ROM still. So the RAM seems to be absolutely fine on this machine, which is great, of course. So the ROM still says 9B is bad. Okay, I think I'm going to have to read up on these diagnostics. Maybe I can figure out what that actually means. If that's the address line that's bad on the ROM, it's definitely showing me something different each time, it seems. But it clearly doesn't like something here. Not sure what that is. But we're going to figure it out. The machine seems to start up fine, at least, without the diagnostics. So I spent some more time with this off camera and played some games from the Penultimate cartridge. And actually the VIC-20 seems to be fine. Some of these games are not for NTSC, so some have strange positioning of the window, which you usually can correct with the cursor keys or the function keys. for the VIC-20 games. I don't have a keyboard connected here. But yeah, it appears to just work absolutely no problems whatsoever. And I played like for an hour or something without any issues. So my theory is that something's wrong with this, the diagnostic card that John sent me. I have an older one that Dave of Tynemouth Software sent me though. I think I bought this actually from him because he was the only one offering these at the time, and I was stuck with a VIC-20 repair at the time that this was very helpful for. Yeah, this did work on the other VIC-20. I tested that and it passed, and John's Diagnostics did the same basically as what they did for the broken, or the formerly broken VIC-20. So let's try Dave's Diagnostic, which I believe is the PAL version of the official Commodore Diagnostic. It's just a ROM cartridge, an EEPROM cartridge that has a RAM expansion in it as well, and you can use some little switches to switch between different ROMs and the Diagnostics. The Diagnostics originally also have some RAM on board, which is used to run the Diagnostics from, because the machine itself has so little RAM that it doesn't make sense to use the RAM on the machine to put the Diagnostics in, so because you wouldn't be able to test the RAM. At least that's what I understand. So we're going to hook the diagnostic harness, which Dave also provided with this. He doesn't sell this anymore, I believe. It's basically made obsolete by the Penultimate cartridge. But I still want to check the ports and see if those work. So I'm just going to hook up the diagnostic harness that came with this diagnostic cartridge that I had for some time, years and years. And we're going to see if that passes the test. The red bar there that we've seen that was a bit flickery, where I suspected it wouldn't be normal, is actually normal. And it's supposed to show a time of day clock and just change while the diagnostics are running. So that is normal. It just didn't show the time of day clock for the other diagnostics for whatever reason. We're going to test this now. Let's see. Dave's Diagnostics in place, everything hooked up, cartridge in there. And if this somewhat passes, I'm going to call it a day, I think, because this VIC-20 clearly works absolutely no problems whatsoever from what I've seen. Yeah, that's our diagnostics. And as you can see, the screen is shifted to the right there. Can't even see the right portion of the screen. That's because it's made for the PAL machine. But it should still work on this machine. Possibly the clock is not working correctly, because I think, as far as I understand, that's derived from the mains frequency. And if this is made for a PAL system, yeah, you can see the clock is not changing. But look at that. It's passing everything else. And it shows the checksums for the ROMs. There's like 3 ROMs on board. Kernel ROM, basic ROM, character ROM. And it checks checksums for all of those to see if it can read the correct contents. So this is not going to pass if you put something like Jiffy DOS or a changed ROM in there of some description, or even a changed character ROM. This is just going to hang. Yeah, the clock is not changing, but as I said, it might be because this is an NTSC machine and this diagnostics is made for PAL, or it might be because the mains frequency in NTSC land, namely the USA mostly, is 60 Hz as opposed to the 50 Hz we have here in PAL, Germany. So that might be an issue with the clock, because the VIA chips, which they actually are, VIA, I think CIA, complex interface adapter, that's not what's on the VIC-20. These have 6522. That's the VIA, the versatile interface adapter. I apologize, I'm working mostly on C64s, and the C64 clearly has CIAs. And so does the Amiga. So yeah, this is now at cycle 9, and I'm just going to call this a successful repair, I guess, at this point. So yeah, this is fully working. I'm probably going to put some heat sinks on this in the longer run, because these chips, especially the VIC chip, get pretty warm in operation. And there's no heat sinks whatsoever in here. There's just a lid for this RF shield compartment here, which doesn't help with heat transfer. There's no tab on here like on some C64s that at least use this as a kind of a heatsink, which doesn't work really well. But yeah, I'm going to glue some heatsinks on here, I think, and possibly replace the electrolytic capacitors in the longer run. And I'm also going to source a proper IEC socket here, 5-pin DIN. I already have some on order, but this was what I had at hand, as I explained. Seems to be fully fixed. Nice. Winner! Just removing the test harness now. So something's wrong with the other diagnostic harness, I think. It's not the VIC-20. That's what it all comes down to. So I'm going to have to double check every connection on the other diagnostic harness, which is a bit more sophisticated with these 3D printed cases, but yeah, I'm going to have to figure that out at some point. Maybe it's just a different ROM, or the ROM got damaged in some way. I'm not sure. We're going to see. Maybe I'm going to make a video about that, if it's interesting enough. Maybe it's just missing a wire that came loose or something like that, or a cold solder joint. Yeah, I think that's it for today. Another VIC-20 back in operation. Thank you so much, John, for sending me a bunch of VIC-20s actually, so there's going to be more NTSC VIC-20 repairs on this channel eventually. Also thanks to the Future Was 8-bit Rod for sending me the Penultimate Cartridge to try out, and Dave for making the working Diagnostics. And I think the other Diagnostics is from Sven Petersen, which I also want to thank again, because he provided a lot of stuff for the retro community just for free, open sourced it all. And he's also a very friendly person, as are all the aforementioned people. And so are you. Thank you for your time. Thanks for watching this. I hope you enjoyed this. There wasn't much wrong with it, but this is what repairs are all about. Finding what's wrong with it and making it work again. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links to that are on my website and in the video description in case you want to give me some support and see more of these videos. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye!